How are you, Sam?
Great, thanks. Bit jet lagged. Other than that, pretty good.
Okay. And what brings you to Australia?
Well, I'm actually speaking at NDC. I used to live actually round the corner, and I moved back to the UK about 4 months ago. So I came back specifically for the NDC conference.
And what percentage of you is Aussie?
I'm wearing RM Williams boots, so that's like about 10%. Now I'm a POM, as they say over here, which is mildly offensive, but I roll with the punches. You know, married to an Australian, and I've got an Australian stepson, so that's about as close as I get.
Right, awesome. Has anyone told you you look like Jon Snow from Game of Thrones?
Yep, it does come up. It does come up, yeah. And also, Brett from Flight of the Conchords gets mentioned a couple of times. Yeah, so.
All right. Now, I believe, what are you working? I have plenty of questions to ask you. I'd love to talk to you about microservices and other things, but what are you working on?
Right now, I set up my own company, so I'm spending time doing consultancy and training for people. I sort of split my time across 3 areas really, which is sort of cloud adoption, microservices type stuff, and CI/CD. Like continuous integration was the thing I really first focused on early in my career, and that's just been a thread that always comes back. You know, people are really interested in. I suppose the thing that cuts through all of that is I try and work with people who say, I've got some software, I want to ship it more quickly. And so bringing all those things to bear to help people go, okay, I want to get it out quick, right? I want to get to my customers quick. And that's sort of what I like doing and helping people go faster, really.
Right, and do you focus on CI or CD? Continuous integration or continuous deployment?
I do a bit of both. I mean, continuous deployment for a lot of clients isn't a right move for them. You know, some organizations, some situations you're in, you do need a human eyeball to go and look at something and sign it off and say, yes, this is good. So especially some regulatory environments, there's always a bit of bureaucracy that's sort of implicit in the domain you're working in. But increasingly, people are looking at more fully automated deployments where you've got fully automated assessment of the quality of your software you're doing it. You know, it's been great that the last 15 years, the shift from manual testing to, no, we're going to write code that are going to validate that our software's working, frees us humans up to go do more creative things. And it's you know, I remember when I first started doing that work, you'd go in and say, wouldn't it be great if you could release your software once a week? They'd look at you like you were crazy. Like, it's a week, we do once every 6 months and we're just fine. Now, you know, I ask that question of training courses stuff I do. Most people are in that place where they're releasing once a month or once a week, and if they're not, they're kind of embarrassed by that.
Right.
And that's been, you know, so actually the flip side is it makes it harder for me to find work to do, because a lot of people are getting these ideas now.
Right, okay. And do you have any favorite CI tools?
There's tools I've used quite a bit. So I used cruise control way back in the day. And
that's dating you?
That's dating me. Well, I used to work for the company that created it, so I used cruise control a bit, cruisecontrol.net. And more recently, I've been using GoCD for stuff that's hosted, and Travis for when I've got off-prem CI. Although I've been looking more at things like Circle CI for sort of the hosted solutions. There's also sort of tools that fit in around that space that aren't quite CI/CD tools, but sort of play in the same area. Things like Octopus is really good.
Yes.
And I'm seeing a lot more people now making use of a tool called Spinnaker for handling the pipeline post the build step. So you'd use something like Jenkins or Go to sort of, okay, my code's checked in, I compile it, I validate the quality of it, and then for the actual pipeline management, you can pop into a tool like Spinnaker, which is allowing you to do things like blue-green deployments in Kubernetes clusters. That's sort of a much more advanced maneuver, but I'm seeing more and more people adopting those sorts of workflows.
So most of the tools that you mentioned there are not the mainstream tools that I see. In the Australia projects that I see, you are typically talking about visualstudio.com or Bamboo from Atlassian and Octopus.
Yeah, I think part of it's sort of skewed because I'm not really a Windows developer. That's not my background.
It's not Windows anymore.
Well, okay.
Their tools are completely cross-platform these days.
But there's not an ecosystem I come from.
Right.
So you know, I'm a Unix and Linux person by that was my background. Now, obviously, when I'm talking about architecture and cloud adoption, you know, that's a much more broad topic. And I do work with a lot of clients. Actually, more than half of my clients who would consider themselves to be sort of Microsoft-oriented developers. But that's just not been my natural background. I mean, Octopus does work, obviously, with lots of different tech stacks. That's been around for quite a while. But yeah, I think there is certainly still a bit of a schism, although Microsoft has done some awesome stuff to embrace more programming language, more deployment platforms. You know, you've got great developer experiences for stuff like Node.js and things in Azure, and do a much better job than Amazon on those sorts of things. And so that's still happening, but there is still, I think, very much I'm in a Linux world, here are the tools I'm going to look at. I'm traditionally in the Microsoft world, here are the tools I'm going to look at. I think we'll see those blending a lot more over time, but there is still a little bit of a schism, which I think is unfortunate because it means we don't learn from each other. We end up recreating almost a similar tool just from a different ecosystem. It's like we had cruise control, and then the .NET people created cruise control.NET, which was basically an identical tool, just written in a different language.
The new Microsoft is very different. We've stopped creating the same tools. Like inside, like we had, unit testing is a good example. NUnit in the old days was seen, and then Microsoft created MS Test. The Microsoft today would never make that move. Yep. They would always embrace it now.
It makes sense as well from a company point of view, because if you can embrace the open source stuff, you don't have to re-implement it. You get to build on top of the efforts of others and help support that stuff. And it's been like really great seeing that Microsoft are significantly more engaging in the open source community. I mean, I think the Microsoft projects are now the top most active projects on GitHub.
Yeah, it's amazing.
It is interesting. I speak to some of the the Free Software Foundation fanatics every now and then. They think, oh, Microsoft is still the big baddie, and it's like, well, actually, no, they're doing loads of stuff great, and they've got a much better story now, I think, about reaching out to open source communities and other organisations that we might talk about. I mean, I'm a bit of an Apple fanboy, right? What do Apple do in the open source space compared to something like Microsoft?
Not much.
Bloody much, no.
What are they doing for developers?
And which is a real shame, right? Because they write software, and it feels like they could benefit from that stuff, and so I think Microsoft making that change and showing how it's changed the way the company's perceived and the benefits that they're getting from that, I think is just going to be another thing that will encourage other organizations to engage. And certainly Amazon is starting to try and move more in that space. Adrian Cockcroft joined Amazon recently. That's kind of his job, is sort of helping drive their engagement with the open source community. So hopefully in the next few years we'll see them shifting as well.
Okay. So you wrote a book on microservices, right?
Yeah. Right place, right time. That was quite got that one out quick.
So microservices, is that just as simple as getting developers to break big things up?
Yeah, kind of. It is. I mean, it's that plus the deployment side, right? Because you can break things up into modules, which is still a perfectly sensible thing to do. In a way, when you really dive into what microservices is, it's more. We've spent 20 years building service-oriented architectures. We've worked out the things that worked well, we've worked out the things that didn't work well, and the things that we did work well, we've kind of bundled it all up in a box and said, microservices. So if you want to call it SOA done right, totally fine by me. In my book, there's nothing really that new in my book. It's more like this is the collective wisdom of a whole bunch of, my own experiences, a whole bunch of people I've spoken to about building these systems well. We've just put a nice shiny new label on it. Which is sometimes a bit embarrassing in a way, right? People go, it's not new, and it's like, no, it isn't. But actually, there are good lessons to be learned from, 70 years of computing knowledge, and we sometimes forget that stuff. So, in the book, I try and bring out all the good work that was done before, and say we need to learn these lessons. Like when I do my training courses, and we will talk about Parnas and his work on modules in the 70s, or Lamport, and why time can't be, why you can't infer causality from time, and all this sort of stuff. And none of that is new. It's more that for people who want to build microservice systems, you have to engage with this whole body of knowledge around distributed systems. And so that's where the things shift a bit from sort of just breaking things apart. Is once you have different processes that talk to each other, there's a whole host of problems that you've got to engage with, like distributed transactions, consistency, latency, and sort of the solutions that you would have to solve those problems within, say, a single process don't actually scale when you've got lots of separate processes. And that's the other angle that you kind of have to bring in there. There's a lot of complexity.
Do we still need to have the term SOA in our vocabulary anymore?
I don't know. I think it's not. No one uses it as much anymore. I think people have just replaced that with the word microservices in a lot of contexts. I think it's a shame in a way because it kind of says that SOA was a different thing or that SOA was bad. I think what it was we had different approaches to service-oriented architecture and it didn't quite work out. I mean, it is a style of service-oriented architecture. But Google, used to say, well, our systems this is a service-oriented architecture. Netflix refers to their architectures being service-oriented architectures. They'll now talk about them being microservice architectures. So to an extent, we've sort of used them interchangeably. I always do try and remind people, partly because I'm getting old, that some stuff was happening in the past, and maybe we shouldn't ignore it because, we'll just repeat the same lessons over and over again.
When we had DDD, they had a term aggregate for a group of related entities.
Yeah.
Is this similar?
You certainly use a lot of domain-driven design concepts in the context of microservices, and so a lot of the time, what you're trying to do is find those aggregates and say, well, I've got a big existing, say, monolithically deployed system. One of the ways you can do this is sort of start identifying aggregates within that larger ecosystem, that larger code base, and actually say, well, actually, this aggregate, effectively, the behavior around this aggregate could become a very nice, sensible boundary in its own right. The thing from domain-driven design we tend to talk about a lot in the context of microservices is that idea of the bounded context that comes out of DDD, which actually, as much as anything, talks about how things communicate with each other. One of the biggest problems, one of the hardest things to get right with a microservice system is how do you create stable boundaries between things? Like within a code base, if I want to change the interface to a method, that's a resharper refactoring, right? It's a safe thing, it's done. And I deploy it in one deployment. If I want to make a breaking change between two services, that's painful, right? I've got to potentially deploy those two services together, or I've got to deploy new versions side by side, then get the consumer to upgrade. So it's a lot more costly when you break those changes. And the stuff from domain-driven design around the bounded context actually all really focuses on how do we identify stable boundaries in our domain. And again, that was stuff being done by some people in the SOA world, and they found that if they did it well, you'd find that stability in service boundaries, and then you wouldn't have this massive cost of change and this huge maintenance overhead. It's also how you ensure that these things are independent, and in many ways, that's probably the thing I focus on most that maybe characterizes microservices as opposed to other types of service-oriented architecture, is that we're really optimizing around making these things independently deployable. Right? That's so much what I talk about is making that happen. And so I can pop that out, I can pop it in. Whereas some of the SOA systems that I implemented in the past, it was like, well, we actually always deploy these 10 things together. It's what some people call a distributed monolith.
Right. Right.
So yeah, it's sort of, and so that shift of independent deployability is how you start getting things like faster time to market. It's how you get things like team autonomy. Because if I work on this service and I can decide when I deploy this service, I don't have to have a conversation about coordinating a release with 2 or 3 or 4 other teams.
Right.
And so if you get all of that stuff right, it's really empowering.
So when you go into companies and just trying to think of the quintessential example of microservices, they might have a customer ordering system. Would you just break it up into customers, orders, invoices, products, and employees, or something like that? It's
sort of. I mean, it may well end up being like that. Absolutely. There is some interesting pitfalls you can fall into sometimes when you take too much of a data-driven approach. So some of the things that I've seen that don't work so well is, okay, well, I've got some data. I'll basically wrap a service around that piece of data. And then you can kind of sometimes end up with services that are just wrappers around database tables. Right. So you do need to think about, well, there is actually functions and behavior that live in there. That there's some techniques you can use to find those boundaries that work quite well. So event storming, rather than, as an example, rather than focusing on starting with the domain entities, it actually starts instead by thinking about the significant domain events in the system, and you extrapolate those boundaries from that. And that's more of an outside-in approach. when people start often with the domain entities, it can sometimes be a bit inside out, and you don't always end up with the boundaries that make it easy to be called.
Can you give us an example?
So yeah, I mean, what you mean is like of a bad service, you mean, or of a?
Well, like how would you break that up?
So
like,
the way I mean,
if you want someone not to think of it as entities, tables.
Yeah. So the approach I tend to use is sort of a capability-driven approach, and so you're thinking about what is a service, right? A service is a place you go to achieve some goals. I'm going to this service to carry out some activities. And so rather than trying to start with the domain entities, I say, well, what are the things that the system needs to do to allow you to achieve some end goal? And so in my workshops, like one of the examples we do is we come up with a domain model for buying CDs online. And so I say, okay, well, here's the first use case we're going to think about, is that a user's going to browse the latest releases and buy a CD. So what are the things that our services need to provide to allow them to carry that out? You do a brainstorm, you start listing, put a post-it note, you put the capability down. So I've got to be able to, find the latest releases. I've got to be able to log in. I've got to be able to look up my details. I've got to be able to go through and add my credit card. And so you start putting these things on post-it notes. It's a real brainstorm exercise. Once you've done that, you can start grouping those sort of capabilities together in things that sort of are related. You can then extrapolate from those capabilities, well, what data or entities would we need for those things to work? And then the boundaries sort of emerge from that. And so I do it with post-it notes and like sticky flip chart paper. I get through so many post-it notes. I've got a friend of mine in the US who does a similar exercise, and he uses Lego bricks. Oh, yeah. And so he literally puts the boards out and he said, well, this is a piece of functionality. This is your viewing my order functionality, and we think it's going to sit here for now. And then he actually connects them with string. So, okay, well, this is going to call that. And they like that because you actually create, if you see a nice tangle in the string, you know it's a problem. But the great thing about it, of course, is it's easy to change, So the teams brainstorm, they try some ideas, they move these things around. And once you've got those capabilities and you group those things together, you can then say, well, what is the data I'm going to need? What are the entities that sort of emerge from that? But the key thing is the capabilities are all about behavior, and you've sort of taken a behavioral approach to that. And that seems to avoid the pitfall of wrapping, just having database wrappers, really.
Right.
So I think that makes sense.
So
I think it's explained better in my book.
Right, okay, all right, I'll read your book. With the advice you give people, I assume most people, you go back to them and they haven't implemented microservices, they haven't broken up enough. But do you ever go and see systems where they've gone too far the other direction, and there's just, they've taken you too literally, and it's now a lot of tiny pieces? Yeah,
I mean, there was some domain, some sort of contexts where microservices are actually quite a bad idea in general, right? I mean, you do see people going too fine-grained, and typically what will happen is they'll start getting hit by performance issues. And if you start breaking up lots of synchronous calls, they'll hit latency issues and they'll merge things back together. And actually, I think you are going to make mistakes, and that's what I try and tell people, which is why whenever I'm working with teams, it's like, well, we're going to be really gradual in how we add these things. So a lot of the work I do is how can we incrementally break out a couple of these things, sit with it, see how it is. But yeah, there's a tool called SnapCI, which was like an off-prem CI tool. They started off 12 services, and but it was a brand new product, so they were sort of evolving the domain quite a lot. They were working with customers, implementing new features. So the fundamental domain was really changeable, and they were getting real issues with the fact that because the domain was changing so rapidly, all their service boundaries were changing so rapidly. And I spoke to the tech lead, a guy called Badgery, and he said, I'm just going to merge it all back together into one thing. And it was the right call. They put it all back into a single deployed process, gave them time to get their heads around what the product was going to do, what it was going to be, how it's going to be used. That helped them get a better, firmer grasp on the domain. They let that sit for a year, and then they split it back apart again. So I actually think for brand new projects, for greenfield development, microservices can be really difficult because you're not going to have that really good domain awareness. Sometimes it's easier if you've got an existing system. There are other domains where microservices are a really bad idea. Actually, if you're creating software that you're going to have your customer install, it's difficult. When you go to a microservice architecture, you push a lot of complexity into the deployment space. And if you're managing the deployments yourselves, you can mitigate that increased complexity by like new tools. You can, okay, we're going to deploy some service fabric, right? And we're going to save a whole load of effort. But you've decided to embrace a new technology to deal with the complexity you've created. If you're giving software to your customer and saying, and they're installing it on your, on their own systems, you used to give them an MSI, and now you go, right, so what we've got for you, we've now got 25 MSIs. You'll be all right with that, won't you? They're just going to look at you odd. And so, in that environment, I absolutely say, no, don't do that. If you're actually, you've got class, you're deploying stuff on the premise of the customer, you probably want to keep it more monolithic. By all means, have modules inside that code base, and those modules can give you some of those abilities to sort of have different teams work on different parts of your code base. But yeah, there's some areas which does not make sense at all.
Okay, is there any metrics that you can tell that you look at, like to whether a team is healthy, towards whether the system has been broken up nicely? Like, obviously you have code complexity and you have sprint lengths, you have velocity. Like, there's lots of different things other people use for different scenarios. But how about a big system? How do you work out nice sized pieces?
It's annoying because, to an extent, why people adopt a microservice architecture can vary. And so if I'm saying, has this been done well, or is this going in the right direction, it's often down to what they're trying to achieve, right? So if an organization is trying to move to a microservice architecture to achieve scale, that's what I'm looking for. How have you improved? Are you now handling the load you want to? If an organization is adopting microservices because they want to go fast, well, are you measuring your cycle time? Are you going actually in the right direction? And so those sort of higher order metrics in a way are a good yardstick. There are other interesting metrics. There were sort of other interesting metrics that come up. From talking to clients, you sort of see different pain points kick in. And it's less about the size of things, it's more about the number, like the number of number of logical services you've got, or the number of physical services you've got. The more of these things you have, the more maintenance overhead you've got, the more you hit problems like, what have I got running? Where are these things? How do I talk to this person? Who works on this service? Anecdotally, at least, just in my experience, when you get beyond one logical service per developer, there are some really interesting problems that kick in, like just knowing what you've got becomes problematic. Within a single monolithic code base, for example, I can just search for code and find like-minded code. And I've got all these things running all over the place. So I see a lot of teams, once they get to that sort of level of scale, when they've got a lot of these things, they're having to build their own tools. They're having to build dashboards so they know what's running where. You're increasingly seeing companies now that are creating tools that will let you see topologies of how these things are connected. Because if you don't have those tools, once you go beyond a certain number of these things, it just becomes too hard to keep in your head. So yeah, certainly it's a number of these things per developer. Is that sort of ratio which I start looking at, and some organisations do that handle that really, really well, and some organisations they hit those problems and they get stuck.
Okay. So you've said that a big important part of microservices is deployment. How do you like to deploy?
In the bath.
Are
you
a big container fan?
I am, but for kind of reasons that I think might be odd for some people. That when we think about how the things are deployed, if we're optimizing around independent deployability, historically how we would deploy lots of services, like in the Java world, for example, I'd put lots of things in WebLogic. So I'd have an application container like WebLogic or WebSphere or JBoss, and I have lots of things sitting inside effectively a big box. The same way you deploy like services behind IIS, right? I've got the IIS sitting and they've got lots of things effectively on the same machine on IIS. That's like the same execution environment, single operating system. The issue is those services can have side effects that affect other services, like a service can use up all the CPU and those other services no longer work, for example. Which is why when we think about microservices and we want independent deployability, what you normally want is these isolated execution environments. So I want really for this thing to be on its own machine if I can, because if I screw something up here, I'm not going to affect somebody else, so I have that independence. Virtual machines work really well there, but they're not necessarily very cost effective. You're running really good isolation for virtual machines, but you've got a heavy cost played by the fact that you're running full fat operating systems in each VM, you've got multiple kernels, you've got the overhead of the hypervisor. Containerized technology gives you isolation. It's not a strong isolation, but it gives you decent isolation. It certainly gives you resource isolation and execution isolation. But it does so without using as many computing resources, which means you can much more densely pack containers than you can VMs with the same hardware. So it can be cheaper and more cost effective. And the spin-up time's great. You know, like I'm not sitting there waiting 3 or 4 minutes for, you know, a VM spin-up. I'm 1 or 2 seconds. And so for those reasons, that's why I tend to look towards the container technology or serverless, like functions as a service for some of this stuff as well, because of that cost-effective, cheap isolation. I think though, if you're in a domain where, especially if your services themselves are services that need quite a lot of resources anyway, then containers might actually not be that beneficial. You might as well try them in a full-fat VM. So think about an organization like Netflix, for example. You know, their servers, you know, smallest server size, or at least when I spoke to them last, was like 32 gig. So this service is going to need a 32 gigs of RAM. Well, I might as well stick it in a full-fat VM at that point. I'm not gaining much. On the other hand, if now I've got loads of services and each of them only needs about 256 megs of RAM, well, actually, that pushes you more towards containerization. I
see, that's nice. And which containers? Are you a fan of Docker?
Yeah, I like Docker. I think it's got really, what it's done very well, it's got a very nice developer experience, nice command line tools. It's a nice, you know, it's a good consistent consistent way of executing it. So it's very, very well supported. I think that the challenge, of course, with Docker is that, you know, the core Docker, of course, is it helps you about managing one machine. So normally what you've got to do is have something on top that lets you manage deployment across multiple machines. And so then you're in the world of looking at things like Docker Swarm or Kubernetes. And like it's great to see like with Kubernetes 1.7 is now supporting Windows containers as well. So I mean, it's obviously one of the new hot things at the moment, right? So these are just platforms that allow me to deploy my containers onto multiple machines, but gives me an abstraction where I'm not actually that worried about where it goes. And so certainly if you're looking to containerize your application, you do need to think about what you're going to use to manage across multiple separate machines, you know, and how are you going to handle, I actually want 5 of these things, but I want to make sure they're spread across 5 different machines so I get some resiliency characteristics. So some people use ECS on Amazon for that. There's also some really good stuff on Azure. It's been really interesting seeing the per second base pricing for containers now have been launched by Azure, which is very useful for a lot of loads. So yeah, so probably Docker for the actual raw containers themselves, but increasingly I think people are spending more time at that platform level.
So in that case, Kubernetes.
Kubernetes is a good one. I think
Mesosphere?
Mesosphere's good. I like Mesosphere a lot. I think the challenge is it's losing out a bit on developer mindshare. Right. So I think Mesosphere, look, if you want, it's round, it's tried, it's tested, it works at massive scale, and it also lets you run mixed loads. Like on the same Mesosphere cluster, I can run, okay, yeah, I've got Marathon running some containers, I could also be running some Spark data processing. So from a general purpose compute grid, it's great. I think the issue is its sweet spot is like running really big grids, really large scale stuff. I mean, I think Siri like runs on a 30,000 node Mesos cluster, right? So, which is fantastic. Most people don't have problems that are that big. No. Whereas what's happening with Kubernetes is they're building abstractions that are really focused on developers, like they do things like rolling restarts and all that kind of stuff. And some of the high level abstractions are really nice. The issue is I'd still consider, you know, installing and running and managing Kube is still work, and they're innovating so quickly that it is a movable feast. So people are absolutely using it in production, but don't be surprised if the way you use Kubernetes now, in 6 months from now, they say, oh, actually now we've changed our mind, you should do it like this. And so if you're interested in using Kube, I would actually start off by using one of the managed providers. I'd spin up a Kube cluster on Google or Azure or something, try it out, sidestep the management side of it and the administration side of it. And there are also other commercial providers that effectively bundle Kubernetes with some tools to help manage it. There are people like Red Hat and Rancher do have offerings in those sorts of spaces. It's definitely the new hotness right now. Like, totally is the new hotness right now. Although I see a lot of love, especially in Australia, for Cloud Foundry, especially for sort of creating a platform on premise. which gives you sort of a Heroku-like experience inside your organization. The story there has sort of been a bit weaker for the Windows Windows ecosystem, the Microsoft ecosystem historically. I mean, obviously you can do .NET Core stuff on that quite easily. And so that's the one area. Some of the corporates I used to work with here in Australia were like, well, yes, we've got some Java stuff, but we've got some .NET on Windows stuff, and you know, Cloud Foundry wasn't a good fit necessarily for that. So I think that they are doing things to address those things, but it's not as obvious a fit. I think with Kubernetes now supporting Windows containers, that whole field's now blown open again. So I think if you're interested in deployment platforms and you want to try something out on the weekend, you're going to spend like a day of your own spare time kicking the tires or something, that's where I'd spend your time.
Sam, the companies that are looking at containers, are they also looking at serverless? And how do you feel about serverless now, where developers have had a hard time of it recently? Most developers have had to become full stack developers. It seems very popular.
Yeah.
And now, not only full stack, front end, back end services, they've got to now understand containers and deployment.
Yeah.
And obviously deployment's really important. They're semi-infrastructure guys.
Yeah.
With serverless, you can just write your code, and that goes away and that's deployed.
Yeah. And you know, I was actually having this conversation just a moment ago. Someone said, so I've got one of my developers wants to do stuff in containers, I've got one of my developers wants to do stuff in serverless, and it's like, well, which one should we try first? And I said, well, do serverless, it's easier. You'll find out quicker. With serverless stuff, you sidestep a lot of the deployment headaches. I mean, there are some constraints on those platforms. I mean, okay, when we talk about serverless, of course, what we're really talking about probably are functions as a service, which is a subset of that stuff, right?
You're talking about Azure Functions now?
Azure Functions, Lambda, and those sorts of things.
So can you just explain Azure Functions first, then AWS Lambdas?
So I don't know Azure Functions that well, but my understanding is they're similar to AWS Lambda Functions. So I basically can take a piece of code, a piece of JavaScript code, a bit of Ruby code, whatever, and that effectively gets executed on demand. These things have typically short execution. They're allowed to run for a short period of time, and when they're stopped running, they're no longer there. They sort of vanish. So I could hit a HTTP endpoint, and it would spin the function up to handle that request. When that request has ceased, the function vanishes. There's not actually anything there. There's nothing running unless it's needed. So that's great because, you know, from a security point of view, it's not there. It's hard to hack unless it's there, right? I'm not worrying about patching the services it's running on because it's actually running on a platform that's being managed for me. It's good from a cost effectiveness point of view because I'm not paying for a service that's running for an hour, even if it's only hit like 2 or 3 times. I'm paying for the 2 or 3 invocations. And yeah, the abstraction around the deployment is just like, I've written a piece of code, and theoretically it should be as easy as I've written a piece of code. Oh, now it's just running over here. The reality, at least with Amazon, though, is that you go through the Getting Started guide for Lambda, and there's like 25 steps. It's actually quite complicated to set up your first Lambda function, and so people are creating frameworks to make them easier to use. But certainly for things that are short-lived, that you know don't need to be stateful, that can just spin up and shut down, they're really useful, and certainly something that now where some people historically would say we're going to break this apart, create containers. Now we've got the headache of how we're going to manage the containers. Now increasingly I'm saying, no, let's just move straight into some serverless functions because that's going to be a lot easier for you. And so normally I'm kind of asking, why couldn't we do that? And then if we can't do that, what else could we do? Maybe that's a container-based solution.
So you've just sprouted all the good stuff of serverless.
Are
you worried about any stuff that would kill it or that make people hate it and get rid of it and go over to containers?
There were some things it's not great for, almost by the nature of the technology. There is a bit of a spin-up time issue for some certain types of. If you really need very fast spin-up of your function, things like JVM-based Lambda functions, they will take longer to warm up when the request comes in. So, a request comes in, if there isn't one already primed, they might have to start a JVM up for you on the back end, so now it takes a while to warm up. And certainly, I've worked with a couple of people who, because of that spin-up time, have not used, they couldn't use it for that particular use case because they needed a decreased latency from what they were getting. Some of the solutions, certainly on Lambda anyway, things like JavaScript seem to have better spin-up times than Java functions. The other aspect is that there's a lot of stuff that we do around building resilient applications that require state management, right? Think about a database connection pool. We have a database connection pool to help us throttle how many calls are going through to a database, right? With a function, there's no database connection pool. I get launched, if I talk to a database, I have a connection and I'm gone again. We don't have that throttling mechanism now. There's a really great talk at NDC Oslo earlier this year from a guy at Bustle. So Bustle are a company that are talked about as being all serverless. It's not quite true. They handle like 60 million uniques in the US. They moved to a bit of a mixed serverless and non-serverless setup. And what they found is as the load came in, all these functions spun up to handle that load. That worked fantastically, but that just generated a load more calls on their Redis backends, and they nuked all their Redis backends. Ooh. Because the Redis backends weren't serverless, they weren't scaling dynamically. And so you get these really interesting problems where unless if the other things you're talking to don't automatically dynamically scale, it doesn't always help. There's also some interesting gotchas where they say the functions vanish and they kind of don't. Like I've seen a lot of people say that the functions, okay, it's not there, but I'm still seeing the connection that came from that function, that connection's still live.
Right.
Because what they're doing is they're keeping these things live so that if you make another request, it's going to spin up fast. And so there's some really interesting things. So the Bustle example, they were hitting like 10,000, the 10,000 connection limit on Redis, but they could only run about 1,000 functions. So how they had 10,000 connections from functions, because there were functions that run earlier that were still kind of around.
Right.
So there are little bits of details in there that can cause issues.
So Sam, we're close to out of time, but I have another couple of questions. I'm just trying to understand the definition of serverless, where you write some code and you deploy it. If a developer just does a web app and sets a couple of parameters and deploys it, is that almost serverless as well?
Yeah, the serverless, I think, one of the characteristics of serverless is that you kind of, although there are computers there, you're not worrying about a computer. You're not worrying about how many copies of a thing I need. So it's sort of any platform where I don't specify how many machines I need and that dynamically scales to handle the load is kind of a serverless platform. So if I say I want 5 copies of this thing, and if the load hits this CPU, add 4 or 5 other copies, which is sort of traditionally how we do that stuff in the cloud world, that's not really serverless because you're still thinking in terms of machines and that scale.
What about an Azure Logic App where you just set up a workflow and throw it over there, and you're not thinking about computers?
Yeah, that's a great example. That feels like that feels like serverless to me.
You don't want to go on the record as...
I think it is. This is the thing, there's no great definition of serverless though.
I thought you were going to tell me.
No, I mean there's loads of definitions out there. I did a talk just a moment ago talking about the fact there's like loads of definitions out there. The key thing for me is serverless in a way is, for me as a developer, I'm not actually worried about physically how many of these things there are, how many of those things I need. It all just happens dynamically for me based on the load coming in. Any platform that fits that sort of mindset for me is serverless. And there's some added things you can throw in there, like you only get charge based on your actual usage and all those sorts of things, but that's less important to me in a way.
So I might finish off. Azure Functions and AWS Lambdas, people are having great experiences. Yeah. We just migrated, we have a program called SSW Link Auditor, which spiders a website, reports on problems. We changed all the architecture to Azure Functions, so it's completely serverless, so much faster. We had a great developer experience, everyone was happy. If the direction continues to grow well for serverless, is there any point to containers?
There are some things that don't quite fit the world. I mean, the functions and Lambda jobs are time limited, right? So Lambda anyway is 60 seconds. There's some things that do take more than 60 seconds. So at least in the short term, there are some things that don't fit in that worldview. There are some computing problems that are handled really well by persisting state. Thinking using something like Orleans or Akka, where you build clusters that actually do work really well by maintaining state across services. And there's some problem spaces that fit really well. But actually, there are parts of our problem spaces that fit that. There's a whole load of issues that don't need that. So I think a lot of our stuff can now start becoming functions. There are definitely some applications that could be purely serverless. I still think there's still computing problems out there where we're going to want something that is more a persistent running process. But I think the interesting thing is going to be that might not be your default choice anymore. Your default choice might be, let's spin up a function.
Well, on that's a nice way to end. Thank you very much, Sam.
You're welcome.
Been awesome
Thanks,
talking to you. And this is Adam Cogan signing off for SSW TV.